Hi guys, this is Mr. Joseph, your chemistry teacher. I'm back with my lecture. Today's lecture is a continuation of solutions and concentration. It's a continuation of our previous lecture on solutions and what concentration that involve what acid-base titration and titration in general. Now we're looking at finding the purity of a substance. There are situations whereby in acid-base titration, the acid or the base, or maybe in redox titration, the reducing agent or the oxidizing agent might contain impurities, might contain certain amount of impurities. So one use of titration is to find the purity of a chemical. It can be an acid, it can be a base, it can be an oxidizing or what? A reducing agent. Now, how do you calculate the percentage purity of of a chemical or one of the substance that is involved in the reaction, or the percentage by mass of it? Now, there's a formula we use to calculate the percentage purity. Percentage purity or percentage by mass, any of them, will be equal to what? Mass of the pure substance. Pure divided by what? Mass of the impure substance. Multiply by what? 100 over 1. So that's how we calculate the percentage purity, or percentage by mass of an acid, or percentage by mass of a base, or percentage by mass of an oxidizing or reducing agent if it involves what? Redox titration. So basically we'll be looking at different calculations. We're going to solve some examples. So let's start. We're going to solve questions based on this. So please, I want us to listen attentively so you can benefit from today's lecture. Having stated the formula, percentage purity or percentage by mass is equal to mass of the pure substance divided by mass of the impure multiplied by what? 100 over what? Over 1. Now let's go to questions without wasting much time. So this is a typical example. 0.982 gram of an impure sample of sodium hydroxide. Sodium hydroxide is the base. This acid-base titration. This question is based on acid-base titration. And sodium hydroxide is the base. An impure sample of sodium hydroxide, that means sodium hydroxide contains impurities, was made up to 250 cn cube using a standard flask or volumetric flask. Then a 25 cn cube pipette full of this solution was neutralized by 23.50 cn cube of 0.100 mole per dm cube hydrochloric acid run in from a burette. What is the percentage purity of sodium hydroxide? So the first thing we need to do here is to write down the equation for the reaction. Write down the equation and balance the equation. So we're going to write a balanced equation. So it's sodium hydroxide, which is aqueous, plus hydrochloric acid, which is aqueous, to give you sodium chloride, aqueous, plus what? Water, which is what? Liquid. So this is the equation, this is the reactant, and this is the product. So we check if the equation is balanced. So each of the atoms present must be the same on both the reactant and also the product. So on the reactant, sodium is 1, on the product, sodium is 1. So it's balanced, sodium is balanced. On the reactant, oxygen is 1. On the product, oxygen is 1. Oxygen is balanced. On the reactant, hydrogen is 2, and hydrogen is 2 on the product. Chlorine is 1 on the reactant, chlorine is 1 on the product. So the equation is balanced. The next thing to do is to calculate the number of moles of hydrochloric acid. So number of moles is equal to what? Concentration times volume divided by what? 1000. So number of moles of hydrochloric acid will be equal to concentration is 0.100 multiplied by the volume, which is 23.50, divided by what? 1000, because the volume is in cm3. So I'm to use my calculator now. So 0.100 multiplied by times 23.50 is equal to divided by 1000. So you have to be equal to what? 0.00235 watt moles. That's the first thing now. Then we'll now go back to the equation. So 1 mole of sodium hydroxide reacts with what? 1 mole of hydrochloric acid. This 0.00235 moles of what? Hydrochloric acid. So from the equation, 1 mole of what? Sodium hydroxide reacts with 1 mole of HCl. Therefore, 0.00235 mole of HCl will give you what moles of sodium hydroxide. So you cross multiply. So it will now be what? 0.00235 times 1, which is equal to 0.00235 moles of what? Sodium hydroxide. So this is the number of sodium hydroxide in 25 cm cube. 25 cm cube. So we're going to calculate the number of moles of sodium hydroxide in 250. So if in 25 cm cube we have 0.00235 in 250 cm cube, what will it be? So you cross multiply as usual. X now will be equal to what? 250 over what? 25 times 0.00235. So 25 here, 25 here is 10. 10 times this. So you now have what? 0.0235 moles of sodium hydroxide. So 0.0235 moles of what? Sodium hydroxide. So I have to wipe up this so that I will have enough space to solve. Please, I want us to listen attentively. It's as simple as ABC. So in 250 cm cube, we have 0.0235 moles of what? Sodium hydroxide. So the next thing to do is to calculate the mass of pure sample of sodium hydroxide. So number of moles is equal to what? Mass over what? Molar mass. So if you cross multiply, mass now will be equal to what? Number of moles times what? Molar mass of what? Sodium hydroxide. So the number of mole is 0.0235. Let's get the molar mass. Molar mass of sodium hydroxide. That is the mass of 1 mole of sodium hydroxide. Molar mass of sodium hydroxide, which is equal to, sodium is what? 23. Oxygen is 16. Hydrogen is what? So the molar mass 23 plus 16 plus 1 is equal to what? 40. So the molar mass is equal to what? 40 what? Gram per what? Per mole. So the mass now will be equal to what? Number of mole, which is equal to 0.0235 times what? 40. So the mass of pure sample of sodium hydroxide will be equal to what? 0.94 gram of what? Sodium hydroxide. So to calculate percentage purity of sodium hydroxide, is equals to mass of what? The pure sample of sodium hydroxide over what? Mass of the impure sample times what? 100 over 1, which will now be equal to what? 0.94 divided by mass of the impure, 0.982. Times what? 100 over 1. To now be equal to, so let's use calculator, times 100, 0.94 times 100 is equal to 94 divided by 0.982. So you get what? 95. So you get 95 point what? 0.71, 0.7%. That is the percentage purity of what? Sodium hydroxide. So as you can see, it's as simple as what? ABC. So you got 95.7% of sodium hydroxide. So the percentage purity of sodium hydroxide in the impure sample of that sodium hydroxide is what? 95.717%. So as you can see, it's as simple as ABC. So the first thing you need to do is to read the equation. Make sure you understand the equation very, very well. Then you write down the balance equation. Make sure the equation is balanced. Make sure the equation is correct and it's also balanced. Then you apply the necessary formulas. So it's as simple as ABC. Please, I advise you to attempt as many questions as possible and feel free to reach out to me. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Once you encounter any difficulty, please don't hesitate to reach out to me. I'm still going to take another example for better understanding. So please, I want us to listen attentively. Let's attempt another question, and I believe you understand it better. So let's go to the next question. Okay, this is example 2. Calculate the percentage of sodium carbonate in washing soda crystals. So this is the next question. Calculating the percentage of sodium carbonate in washing soda crystals. So 5.125 gram of washing soda crystals are dissolved and made up to 250 cm cube of solution. A 25 cm cube, 75.0 cm cube portion of the solution requires 35.8 cm cube of 0.0500 moles sulfuric acid for neutralization. So you have to calculate the percentage of sodium carbonate in what? In the crystal. So sodium carbonate is a major component of washing soda. So it's present in washing soda. So it's a major component. So the first thing we have to do is to write down the equation for the reaction. Because washing soda, which would contain a greater percentage of sodium carbonate, reacts with sulfuric acid. So it's to write down the equation. That is the first thing we have to do here. So write down the equation, which is sodium carbonate, which is Na2CO3 aqueous plus sulfuric acid aqueous to give you what? Sodium sulfate aqueous plus water liquid plus carbon dioxide gas. Which is gas. Okay, then we'll have to check if the equation is balanced. On the reactant, sodium is 2, on the product, sodium is 2. On the reactant, carbon is 1, on the product, carbon is 1. On the reactant, oxygen is 3 plus 4, which is 7. On the product, oxygen is 4 plus 1, 5, 5 plus 2, 7. Oxygen is balanced. On the reactant, hydrogen is 2. On the product, hydrogen is 2. It's balanced. On the reactant, sulfur is 1. On the product, sulfur is 1. So the equation is balanced. So the next step is to calculate the number of moles of sulfuric acid. So number of moles of sulfuric acid, number of moles is equal to concentration times volume over what? 1000. So number of moles of sulfuric acid will be equal to The concentration is 0.0500 multiplied by the volume, which is 35.8 cm3, divided by what? 1000, because the volume is in cm3. So if you multiply 0.01500 times 35.8, then divide by 1000, you get 0.00179 moles of what? Sulfuric acid. Now you go back to the equation. 1 mole of sodium carbonate reacts with 1 mole of sulfuric acid, then 0.0 of sulfuric acid reacts with what moles of sodium carbonate. So the next thing you do, you cross multiply. So number of moles of sodium carbon, which is X, is equal to 1 times what? 0.00179 is equal to 0.00179 moles of what? Sodium carbonate. So the same number of moles. So this is the number of moles of sodium carbonate in 25 cm3. So we are going to calculate the number of moles of sodium carbonate in 250 cm3. So I'm going to erase this so that I'll have enough space to solve. So I have 0.00179 moles of sodium carbonate in 25 cm3. So in 250 cm3, what moles are we going to get? So you cross multiply. You now have what? X now will be equal to what? 0.00179 times 250 over what? 25. So this cancel this, yeah? So you have 10. So 10 times 0.00179. So you have 0.0179 moles of what? Sodium carbonate. So this is the number of moles of sodium carbonate in 200 and what? In 250 cm3 of solution. So the next thing we're going to calculate the mass of sodium carbonate. So that is the mass of the pure sample of sodium carbonate. So number of moles is equal to what? Mass over what? Molar mass of sodium carbonate. So when you cross multiply, the mass now will be equal to what? Number of moles of sodium carbonate times the molar mass of sodium carbonate. So the mass now will be equal to, what is the number of mole? 0.0179 times the molar mass. Let's calculate the molar mass of sodium carbonate. So sodium is 23, so 2 bracket 23 plus carbon is 12 plus 3 bracket 16. So let me use my calculator. 2 times 23, which is 46, plus carbon is 12, plus 3 times 16, which is 48, plus 48. So the molar mass is 106. That's the molar mass, 106 gram per mole. So it will go to 0.079 multiplied by 106, which will now be equal to so you have 1.897 gram. 1.897 gram of sodium carbonate. So that is the mass of what? Sodium carbonate. So we have to calculate the percentage purity. We have to calculate the percentage of sodium carbonate in the crystals. I need to say the percentage of sodium carbonate in the crystal. So the mass of pure sodium carbonate is what? Is 1.8977 gram. So I have to erase this for space. So percentage of what? Sodium carbonate in the crystal will be equal to what? The mass of the pure sodium carbonate over mass of what? Impure, which is the crystal, times 100 over 1. So I have to erase this. One 1.897 divided by 5.125 times 100 over 1. So now it will now be equal to, so 1.897 times 100 divided by 5.125. So you have 37.01%. So that's the percentage of sodium carbonate in the water, in the crystal. So as you can see, that it's as simple as what? ABC. All you need to do is to follow the steps. You write down the balance, write down the equation, make sure the equation is what? Make sure the equation is balanced. And after that, you apply the formula. So you can see as simple as ABC. Please, all you need to do is to attempt as many questions as possible. And feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So before I end the class, I'll give you a few tasks to solve. Please attempt questions on your own, and reach out to me for any difficulty. Please subscribe to my YouTube channel, like, comment. So I'm Mr. Joseph, your chemistry teacher. So feel free to reach out to me in case you encounter any difficulty. So I'll give you the questions for now. So let's take the tasks. So these are the tasks. So please, I want you to attempt these tasks. Just follow the formula, follow the steps. It's as simple as ABC. Use the correct formula. Feel free to reach out to me if you encounter any difficulty. Solve as many questions as possible. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you very much. Please subscribe to my YouTube channel. Go to the comment section and drop your comment, like, share. Thank you for listening. I'm Mr. Joseph, your chemistry teacher.